Hi, it's Terry Dennery, the MathWorks. So my son showed me this interesting physics problem. I thought, hey, this would be kind of a cool demo. And so it's one of those cranes that uses these cables. And the cables are in pretty significant tension, and they are used to essentially support this big beam right here. And then, kind of on the end of the beam, we basically carry weights, right? So I kind of schematically kind of put it together and put together kind of the useful information, right? And I'd say the angles are particularly important. And the basic questions are what's going to be the tension in the blue line, and then what's going to be the forces carried by that pivot point right there. Think of it like a bearing, right? And the general strategy, and so I'm going to do a click here, is to resolve these vector forces into components that are useful for us. And kind of general approach will be let's use summation of moments on the system. In static equilibrium will sum to zero. And so we're going to be interested in the perpendicular components of each of these. And again, just kind of working through the geometry, we see that the angle, between the vertical and these perpendicular components, well, that's going to be theta, and therefore this projection, it'll just be the cosine of theta multiplied by the magnitude of the vector. So anyways, it's a useful picture, and so we'll use the snippet tool to get a copy of that. All right, so let's go to MATLAB. And we'll do a live script. All right, so I learned some useful shortcuts. So Control E will toggle us between the code mode and the text mode, and I'll just go here and I'll paste that picture in. Okay. And so let me just, oops, like the undo button for sure. Right, so let's get that. And now let's get back into code mode. So let's start typing in some of this. M weight equals 4,000. And we'll put in the units as a comment of kg. Now, one of the other great shortcuts I learned is what they call the zoom in or whatever, but make this bigger. And I'm going to zoom this a few times so we can really see this much clearer. All right, and that will, actually, here's what we're also going to do. Let's move that like that. And I think that'll work for us pretty well, right? So anyways, let's go M weight. Let's go M beam is equal to 2,000. And L beam will be equal to 30. And I'll put the units in here of meters. All right, and so let's get these two angles. Theta in degrees will be equal to 30. And our first calculation will be theta in radians equal to theta times pi divided by 180. All right. And, oops. I always think it's good to hit the run button a lot. So anyways, there's our first calculation. All right. Okay, let's get alpha in there too. It's equal to 10 degrees. Alpha rad. Times pi divided by 180. All right. Okay, now the questions that we've been asked to solve are, what's the tension in the blue line, but also what's the force acting on the bearing, right? And so I'm going to just capture those questions right now. What is tension in blue line? What is force let's call it reaction force even, at the beam pivot bearing. Okay, all right, and so the first one's really about, the sum of the moments is equal to 0, and that really the moments are going to be, three sources. The weight of the beam, which acts through the middle of the beam. I didn't do my screen capture as good as I wanted to because I wanted to really emphasize that perpendicularity, right? But anyways, hopefully recalling from memory, that this angle of operation, boy, that's pretty bad. I messed that up. Let me go back to PowerPoint and just really emphasize this. Here's the picture I really wanted. Is the projection of these forces, onto kind of the perpendicular direction. That'll be the cosine theta times, essentially the amplitude of those forces. So those are going to be the forces we'll use, and then we'll just, kind of calculate the moment arms based on the location on the beam where these forces act. So. And so I think what I'll do is I'll actually go into code mode even right now, and so let's just get these while we just talked about it. And so I'll call moment underscore mg will be equal to m beam times, I keep on forgetting to do that, so let's put g in here right now. G is equal to 9.8, which of course will be meters per second squared, and so then we multiply by that g right there, and again by that cosine. And cosines need to operate on things expressed in radians, so we use the radian option. And then the moment arm for the center of mass, well, that'll be half the beam length. It's L beam divided by 2. Right. Now this next one's almost, one more thing. Which direction would that moment make the beam rotate? Well, make it rotate clockwise, and again using right-hand rule, it would rotate in the direction of my fingers with my thumb pointing in, and therefore, clockwise turns out to be a negative, moment according to our right-hand rule convention. So, let's go ahead and put that minus sign in there too. Right, and so, anyways, the main point of why I'm going to do what I'm about to do right now, which is just kind of, well, let's go ahead and do it. So let's go here, copy that. So we're going to basically use that same kind of form to get the moment generated by the weight. Right, so instead of being the beam, it will be m weight. And instead of the moment arm being the length of the beam divided by 2, in this case it'll be the full length of the beam. And so with that we got these two moments. And so now I want to just kind of get back into this text mode to kind of show my strategy for doing this is the summation of moments will be equal to 0. Right? And so the moment associated with that tension, well, it's going to be the tension, which we don't know yet. We're going to solve for it through this equation. And that the force will, in this case, the perpendicularity, well, that's going to be kind of the opposite, segment length according to the location of the angle that's been provided to us, which is 10 degrees. So anyways, it will be times sine of alpha rad. Okay, and its moment arm will be L, the length of the beam as well. Okay, and so summing that with these two moments, oops, I gotta get that name right. This one we call weight, will be equal to 0. And so just to kind of be as efficient and brief as possible, I'm going to go ahead and do the move of subtracting both sides by these values. So let's go minus moment mg minus moment weight, right? And now I'm going to, well, it doesn't matter if those parentheses are there or not. So, but what we are going to do is we're going to actually solve according to this. And so we just kind of paste that in. It's kind of convenient those are there now because of Roy to solve for t. I really just need to divide by all that. So let's go Control X. Let's bring it over here. And let's turn those multipliers into divides. Okay. And we'll hit run. And there's our tension right there. Right. So I'm going to stop the video right now, and then we'll do a part 2, and we'll just kind of get this last piece, which is about the forces at the pivot point. All right. Be back in the next video. Thanks.